Hello students. Next we move on to the concept factors on which the resistance of a conductor depends. So we know that what is resistance? Resistance is a property of a conductor. It usually resists. The resist means oppose the flow of charges. So flow of charges means what? The current is flowing through the circuit. We know that what is electric current? Electric current means flow of charges. So this flow of charges is opposed by this property. The property is called what? Resistance. Yes, it will resist or oppose. Oppose means restrict the flow of charges. Yes, that is called a what? Resistance. If the resistance is very high in the circuit, if the resistance is very high, so the flow of charges is usually decreases. Yes, if the resistance is very high, flow of charges is decreases. The flow of charges means current. The current is I. I is decreases. If the resistance is decreases, the flow of charges or current in the circuit is increases. Okay. Now we will find out this resistance of a conductor is depends on which factors. Okay, this resistance of a conductor is depends on which factors of the given wire or given conductor. So see here, this resistance is depends on length of the wire. Length of the wire and area of cross section. Area of cross section of the wire. Another one is nature of wire. Nature of wire. The length of the wire is represented by L. Area of cross section is represented by A. So how this resistance is depends on this length and area of cross section. See here, the resistance of a material is directly proportional to length of the wire and inversely proportional to area of cross section. You should remember that because it's very important. Very important. Okay. So this resistance of a material is directly proportional to length of the given wire and area of cross section. Okay. See here, when you remove this proportionality constant, we get R is equal to rho into L divided by A. Okay. This rho is a proportionality constant. This rho is proportionality constant. Okay, and this is called a electrical resistivity of the material. This is called as resistivity. Rho is called a resistivity. Don't get confused. R is a resistance. Rho is resistivity of the given material of the conductor. The SI unit of resistivity is, see here, rho. We can write it as rho. Then it is symbolically we can write it as like this. Okay. Or it can be written as also ohm meter. We can it's also unit is become ohm meter. Resistivity unities. Okay. So this is the resistivity. It is a characteristic property of the material. You should remember that it is the characteristic property of the given material. So rho is the resistivity, R is resistance, L is length of the wire, A is area of cross section. And see here, if the length is increases, if the length of the wire is increases, here if the length of the wire is increases, the resistance also increases. Remember that. Okay. If the area of the cross section is increases, resistance is decreases because resistance and area of cross section are inversely proportional to each other. Okay, if the length is increases, resistance is also increases. If the area of cross section is increases, resistance is decreases. Okay, see the relation, see this relation first. Okay, so and the rho is resistivity. Resistivity is the proportionality constant. Also it is the characteristic property of the nature. Its unit is rho. You can write it as like the Simon, or we can call it as also Simon or ohm meter. Okay, and here this resistivity is the characteristics of the given characteristic property of the material, and here metals and alloys have a very low resistivity and they are good conductors of electricity. Remember that metals and alloys are have very low resistivity and they are used as a good conductors of electricity. And insulators like rubber have resistivity range is 10 power 12 to 10 power 17 ohm meter. Its range becomes like rubber and glass are also insulators. Okay, so we know that what are conductors and insulator. Conductor means which is allowed to current. Okay, insulators means which does not allow to current to flow through the materials. Okay, and one more thing here, you see that in the book the table 12.2, see the table, they gives the what conductor, alloys and insulators and materials. Okay, what are the materials or sorry, which are the materials are conductors and materials of alloys and insulators, and also they given resistivity. Okay, also they given resistivity. From this table we conclude that the resistivity of the alloys are very high. The resistivity of the alloys are very high as compared to the other metals. Okay, so and one more thing here, alloys are do not oxidize. Oxidize means do not burn easily, do not burn easily at higher temperature. Because of that reason these alloys are usually used in electrical heating devices like electric iron, toasters, another electrical heating devices. Okay, because it do not burn at higher temperature, do not oxidize at higher temperature. Because of that reason the alloys are used in commonly used in electrical heating devices. And the tungstens, you know, the tungsten is used in filament of electric bulbs. You know that bulbs you were used in your home, so this is the filament. Okay, the tungsten is used in the filaments of the electrical bulbs, whereas copper and aluminum are generally used for electrical transmissions lines. Remember that copper and aluminum are usually generally used for electrical transmission lines, and tungsten is used in electrical bulbs, filaments of electrical bulbs. And copper, see that here, electrical these alloys are used in electrical heating devices. And tungsten is used in filament of electrical bulbs. And copper and aluminum used in electrical transmissions. Electrical transmission lines. Okay.